Hello, Algebra students. Mr. Lawrence here with your flipped lesson. And guys, I gotta tell you, today's lesson, some students in the past have found this difficult. But you know what? You guys are so smart. This is so simple. I'm gonna make it easy for you. Did you hear that, Kyle? This is gonna be easy. All right, today we're gonna be solving equations with variables on both sides. Some kids panic, like in examples 1 and 2 here. All right, they panic. They just don't know what to do. All right, here's all you have to do. It bothers you that there are x's on both sides of the equation, right? Well, Nicole could tell you that we're going to take away what bothers us. I mean, think about it this. Let's say that I brought a special teaching assistant into the classroom on Monday, and it was a big, sweaty, 8-foot gorilla. And he was walking around and, very scary because, it wouldn't be cool like if I brought a puppy into class. This would be like scary because gorillas are big and strong and just full of muscle and all that kind of stuff. And it would impact your learning. You'd be afraid of it, right? It would bother you that gorilla was in the room. But if Mr. Morgan walked in and took the gorilla away, you'd be able to calm down, right? It's the same thing. Here's the problem. You don't know what to do when you see variables on both sides. It freaks you out. You got a 6x here and a 5x there. Well, I'm going to tell you, take one of them away. And take away in math class implies subtraction, does it not? I'm going to take the 5x away from the left-hand side. In other words, I'm going to subtract 5x. But if I do it to one side of an equation, I have to do it to the other. And notice when I say the other side of the equation, I'm actually going to the other side of the equal sign. My new equation becomes x plus 5, and that'll equal negative 10. Now it should look like an equation most of you can solve in your head, but we're going to show our work because it's always a good thing to show our work, especially if we make a silly mistake. Excuse me. Now, after grading your quizzes, some of you are having a lot of trouble with a problem like this. Please stop and think about it. Don't just guess. If you have 10 negatives and you have 5 more negatives, altogether you must have 15 negatives. You just got to commit that to memory, guys. When the signs are the same, it's an addition problem. 10 and 5. 10 what? 10 negatives. 5 more negatives. I'll bet you Nellie could tell you that. It's real simple stuff. Remember, maybe it was Megan I was talking to on Friday, and I kept telling her, 3 apples plus 7 apples, and she'd say 10 apples. I always made her give the label, right? So this is like 10 negatives plus 5 negatives would be 15 negatives, right? Or negative 15, and there is your answer. If you wanted to check it, which is always a smart idea, you could do 6 times negative 15 plus 5. I believe that 6 15s is going to be 90, so it's negative 90 plus 5, negative 85. All right, then on the right-hand side here, we'd have 5 times negative 15. And I must have pressed the erase button. Oh, there it goes. Then take away 10, and that 5 times 15 would be 75. It's negative 75 minus 10, negative 85. And you see they are equal to each other, so therefore we did it right. I'll give myself a big green star. All right, I'm going to go through the next couple problems a little quicker so I don't take up too much of your time. Hopefully you're thinking, looking at number 2, you should be thinking of what you want to take away. You could take away the 7x, and I'm going to go ahead and take away the 3x actually. A little trick, I'm going to suggest you always take away the smaller coefficient of x, okay? Sometimes it'll save you a step later on. I'm going to get negative 8 because those are going to cancel. I'll be left with 7x minus 3x. That would be 4x plus 12, and now I just have a 2-step equation. So I'm going to subtract 12 from both sides, listening to Saddam, and then those will cancel. I'll be left with 4x. And if I have 8 negatives and 12 more negatives, I will altogether have 20 negatives. These don't cancel each other out. This is an addition problem. When the signs are the same, it's addition. I don't see a multiplication symbol, right? Okay, so I'm going to divide each side by 4. Divide by 4. And then x will end up equaling -5. And I'm going to leave it to you to verify that I did not make a mistake there. You can check it by plugging -5 in for x. All right, I'm going to move that up just a little bit. Or maybe I should move that down. There we go. Okay, that'll work a little bit better. All right, if you're feeling really good about this, go ahead and pause and then try to solve these two. If you still need to see me do them, that's fine. All right, here's my solution. I'm going to add 4x to each side. Remember I suggested on the previous problem that you take away the smaller amount of x's. -4 is smaller than -2, and taking away a negative is the same as adding a positive. So what I really had going on here was taking away a negative, but those would change into a positive. So taking away a negative is adding a positive, and my new equation becomes 2 equals 2x minus 10. So now I'm going to add 10 to each side, and then I'm going to go 2x, that's going to equal 12, divide each side by 2, and I'm going to get x is the same as 6. All right, last one in a unique situation here. I'm going to subtract 6x from each side. I'm going to get 11 equals -3. Now that should bug the snot out of you. 11 equals -3. When does 11 equal -3? It never equals -3. That means that this problem has no solution because pardon me, I have the football game on and I just got distracted by a play. No solution because I ended up with a statement that is never true. Okay, the x totally disappeared. I end up with a statement like 11 equals -3. That could never be possible. All right, that's your lesson for today. Mr. Lawrence signing off. Good night, everybody.